Hi everybody, my name is Massimo Banzi and I'm one of the co-founders of Arduino. Welcome to the third video about the Arduino Robot sponsored by RS Components. In this video, David Quartielles and Kyun Yang are going to explain to you how to add different kinds of sensors to the robot to avoid obstacles and create strategies. So in this video, we're going to go deeper into the programming and the building of behavior with the robot. So I'm sure you will enjoy it, and over to you, David.
Hello, this is David.
This is Shin.
Today you're going to see how to use different techniques to avoid obstacles using different types of sensors. First, we're going to check how to use an ultrasound sensor, then an infrared sensor, and then a self-made sensor with an ultrabright LED and an LDR. Jun?
Yep. Okay, let's have a look at the ultrasonic sensor. So this is one that you can get from an electronic shop. And you just need to solder 3 wires to it, and we use a Tinkerkit cable to connect it to the robot. So what we want to do is connect it to port M1 on the robot, and then you face the sensor directly to the front. You can use tapes or anything that's attached it to the right position. Okay, this should work.
We plug it to the computer, and we provide you with an example that would help you connecting directly this particular brand of ultrasound sensor. It's the example called Runaway Robot. The idea with this example is that the robot is going to detect an obstacle and then turn in a direction to try to avoid the obstacle, and if there is no obstacle, then it will try to move forward again. We can take a look at the code. Of course, you first have to import the Arduino Robot library. Then you decide which pin is going to work with the sensor. Start the robot, start the screen, show the logotypes, and then we check the distance. Check distance is a function, and if the distance is less than 40 actually maps to more or less 20 centimeters away from the robot. It will show an unhappy face on the screen. We'll stop the motors, wait for a second, turn 90 degrees, change the face on the screen, and start moving again. Here we go. I'm going to be ready to stop it. You see, it stops, it turns, it turns and it continues moving. It will come towards me. I will just stop it. It detected the computer. So, you can see that right now it's showing sad face. That's about using ultrasound. Ultrasound sensor, like this one, you can find in 2 different types, with 1 single ultrasound cone or with 2 ultrasound cones. Ultrasound is working over the 40 or more kilohertz, and it works by sending an ultrasound signal that is like the bats, it's like a sonar, sends a signal, bounces in an object, and then it returns. And then the sensor is able of measuring the amount of time that it takes for the signal to fly over the air and come back. Now we're going to explore a different type of sensor, which is the infrared sensor. This is an infrared sensor, and as you see, this one has an emitter and a receiver. It's very different from this one because it works on the invisible range of light, while this one works in non-audible range of sound. Okay? This particular one is very good for robotics because it works between 10 centimeters and 80 centimeters. So it comes with a special connector. What we did is to hack it, like here, to work with an ending from a Tinkerkit connector, so it's very easy to mount it on top of the robots. So now here we have the robot with 2 ultrasound sensors mounted on top, like this one we saw earlier. Okay, it's a very standard sharp distance sensor.
Okay, so we have programmed this robot. So when the 2 sensors, either of them is blocked, the robot will turn to another direction. Let's turn it on. So let's first block this sensor on the right and the one on the left.
So now we're going to see how this program works directly here on the computer screen. It's a very simple example. So first of all, we call the Arduino library for the robot. Then we have defined a threshold of 600. This sensor, when you're more or less at this distance, is detecting 600. Below this point is going down, and then we read the pin for the one sensor we call sensor right, that is the one that you just touched, and there is sensor left, and we print that information to the computer screen, so we could actually, by connecting the computer to the robot, we could see what's going on. And depending whether the sensor is activated and the other is not activated, the robot will turn in one direction, and if it's the opposite thing, it will turn back. As you see, we have chosen speed of 160 for the turning, so otherwise the robot turns really, really quick and it's really hard to show live. So now we're gonna see our final example, where we're gonna see how to build your own distance sensor using a very strong ultra-bright white LED and an LDR.
Now I'm going to teach you how to make your own distance sensor by using a Tinkerkit LED and an LDR sensor. So the principle is like this. The LED will be emitting light, but and when the robot is getting close to a flat surface, the light from the LED will be reflected back into the LDR sensor, and then the robot will know that it's getting close to an obstacle.
So we'll turn on the robot now and see how it works, and I will show you the code in the computer. So you see it's a very, very simple code example. It's very similar to the other two that we saw earlier, with if this is a self-made sensor, you could build yourself out of discrete parts. So here you go. The robot is running now. It's not close to any object, and therefore it's not reacting. As soon as we put an object close to it, you see we're all around, and as soon as it finds that there is nothing in front of it, it will stop. It's a very simple example. Now we're going to connect the robot to the computer using a normal USB cable, mostly just to check that the same code is actually sending data back to the computer, and we can read that information straight on the computer screen. The program, as you see here, is using the Arduino Robot library. We are setting up a threshold of 740 for the values read by the LDR. This you have to configure to accommodate the light in the room you're in. We start the robot, we start the serial communication, we write this pin, which is the pin where the LED is connected to, on, so that the light is always on, and we start reading inside the loop for the value of the LDR. We read it, we print it out, and if the value is smaller than the threshold we determined up here, we will print out turn left, and then it will turn left. So let's just check that we have the right serial port, and we do, and we just open the serial port communication to the robot. You will see in the window here how it's reading a value that is above 740, and if you tune, you can put your hand in front of the sensor. You see, when the sensor triggers 740, it prints out turn left, which is the action that the robot is executing using the motors.
So in today's video, we showed you how to use a distance sensor to detect obstacles. We showed you how to use an ultrasonic sensor, a pair of infrared sensors, which detects whether the obstacle is on the left or the right, and also how to build your own distance sensor with a LED and a LDR sensor.
This was our third video on the series on how to use the Arduino robot. Thank you very much for watching, and don't miss our next chapter where we'll see how to make your robot follow lines.
See you next time.
See you next time.
Okay, so that was great. So you learn how to use sensors and how to build behaviors. And in the next video, we're going to show you how to follow lines and use some others of the sensors that are embedded into the robot. See you next time.